This is adding and subtracting polynomials. The first vocabulary we're going to look at is a monomial. A monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. So a monomial is not an addition problem. A monomial is not a subtraction problem. A monomial cannot have a variable in the denominator. A monomial cannot have a variable for an exponent. The variable must be a whole number exponent, which excludes negative exponents. The degree of a monomial is the sum of the exponents of the variables in the monomials. Constants, their exponent is 1. We do not count the exponent of a constant, only variables. So a number like 10 would have a degree of 0. It doesn't have any variables and they don't have any exponents since they're not there. In 3x, I've got a variable of x. The exponent on that x would be 1. So the degree of that monomial would be 1. In the problem 1/2 a times b to the second power, the degree of the monomial is 3 because a is a variable with an exponent of 1 and b is a variable with an exponent of 2 and 1 plus 2 is 3. On the monomial negative 1.8 m to the 5th power, the degree is 5 because we only have one variable and its exponent is 5. A polynomial is a monomial or a sum of monomials. And remember, we can take any subtraction problem and change it into an addition problem and make it a sum. So an example of a polynomial would be 2x to the 3rd power minus 5x plus x squared plus 12. Each of the individual parts of the polynomial are referred to as terms. A binomial is a polynomial with 2 terms, like 5x plus 2, whereas a trinomial is a polynomial with 3 terms, like x squared plus 5x plus 2. When we're finding the degree of a polynomial, we don't add anything up. We just look for the greatest exponent in the polynomial. So in the problem, 2x to the 3rd power plus x squared minus 5x plus 12, our largest exponent is 3. That is our degree. Standard form is when you write a polynomial with the exponents decreasing from left to right. So your largest exponent is the one you start with, your smallest exponent is the one you end with, and then constants, they go at the very end, where we don't count them as having variables or degrees at all. The leading coefficient is the coefficient of the first term of your polynomial when it is written in standard form. A closed problem is when an operation performed on any 2 numbers in the set results in a number that is also in the set. So if we take the set of integers as our example, negative 2 plus 4 is the addition of 2 integers. It results in an answer of 2, which is also an integer. So it's a closed set. The addition of the integers result in an integer. Now we're going to take a look at some examples. So the first thing that we're going to do is to try to find the degree of a monomial. So here we have some different monomials, and we want to find the degrees of these monomials. Remember, only the variables count towards our degrees when we're talking about a monomial. So in this case, 5 is a constant, doesn't count at all. I have one variable x, and it's to the 2nd power. It's the only variable, so the degree of this monomial is 2. In this case, I have 2 variables, x and y. X is to the 1st power. I can add in my ghost 1 here. Y is to the 3rd power for a total degree of 4. Here I've got x to the 3rd power and y to the 3rd power. total degrees of 6. And in this case, -3, I just have a constant. Constants don't count as having exponents at all in our case of monomials, so a degree of 0. In this next problem, example 2, we're asked to write 15x minus x to the third plus 3 in standard form. Identify the degree and the leading coefficient of the polynomial. So standard form means we start with the monomial with the largest individual degree. So I'm going to start with -x to the third. Then I've got 15x with the degree of 1 plus 15x, and I'm going to end with my constants. So in this case, this -x to the third, I can add in my ghost 1. In 15x, it's to the first, I can add in my ghost 1. So I'm looking for the degree and the leading coefficient of the polynomial, now that it is written in standard form. So the degree is going to be the largest degree we have in the polynomial. So in this case, our degree is 3. Our leading coefficient, since this is the first number, first term in my polynomial, is -1. Now let's look at taking more polynomials, making sure they're written in standard form, identifying their degree, and classifying the polynomial by the number of terms it has. So in this case, this is just a monomial. Monomials count as polynomials, and since it's only one term, it's really already in standard form. It can't be written any simpler than -3 times z to the 4th power. Now, since there is only one term here, it's also easy to find our degree. The largest degree is 4. And since there's only one term, this is called a monomial. In this case, I see that I have the variable x, and I have a x squared minus an x, this would be to the 1st power, plus 4. So my highest degree is 2. Since I've got 1, 2, 3 terms here, this would be a trinomial. In this case, my variable is q. I have a q to the 5th power and a q to the 1st power. So my highest degree is 5, and since I have 2 terms here, this is a binomial. Lastly, we're going to look at adding and subtracting some polynomials. So in our first example here, we're adding some polynomials. So the first thing I did was make sure that my entire problem was addition, which meant where I had minus 5x squared, I changed it to plus negative 5x squared, and where I had -1, I changed it to plus -1. Once it's all addition, I can remove my parentheses, and I rewrote it here in standard form. So I had 2x to the 3rd plus x to the 3rd plus negative 5x squared plus 2x squared plus x plus -1. Now I have some things that tied in their degrees, and I want to combine those things. So I have 2x to the 3rd and just a single x to the 3rd. That becomes 3x to the 3rd. I had a negative 5x squared and a 2x squared. That becomes negative 3x squared. I only had one x and I only had one constant, so they remain the same. My final thing is I'm going to combine any plus negatives that I had into minuses. So my final answer here would be 3x to the 3rd minus 3x squared plus x minus 1. So let's try one here together. So the first thing I want to do is make sure it's all addition so I can remove the parentheses. So I'm going to make this plus -6, and that's my only one I have to change. Now I'm going to write it in standard form. So I've got a 3x squared plus an x squared plus an x plus 4x plus -6 and plus 10. Now things that are the same degrees are going to be combined. So 3x squared and x squared is going to become 4x squared. X and 4x is going to become 5x, and negative 6 and 10 is going to become 4. And since I don't have any plus negatives in my problem, that is my final answer. So let's take a look at a subtraction problem. In our subtraction problem here, I'm going to also change anything that is subtraction into addition. So I had here a minus. This became plus negative, and I put in my ghost 1. And here I had minus 4, it became plus negative 4. So in this case, I want to distribute my negative 1. So I'm starting with 4n squared plus 5, plus, when I distribute my negative 1, this becomes plus 2n squared. When I distribute my negative 1, this becomes plus negative 2n. And when I distribute my negative 1, this becomes plus 4. I then rewrote it in standard form. So 4n squared plus 2n squared plus negative 2n plus 5 plus 4. My n squareds combined to give us 6n squared, and my 5 and 4 combined to give us 9. This negative 2n didn't have anyone to combine with, so he stayed the same. And for my final answer, I combined my plus negative into a minus. So my final answer was 6n squared minus 2n plus 9. Let's try one together. So I'm going to make this minus 3x plus negative 3x. I'm going to make this plus negative 1. Here I'm going to make this minus x plus negative 1x. And this minus 8 plus negative 8. So now I'm going to distribute my negative 1. Doesn't affect the numbers in my first parentheses, but negative 1 times 3x squared becomes negative 3x squared. Negative 1 times negative 1x becomes 1x, and negative 1 times negative 8 becomes plus 8. So I'm going to rewrite this so that it's in standard form. So I can combine my x squareds into a single x squared. 4 minus 3 will give me 1. 1x squared is also x squared. My negative 3x plus 1x is going to become negative 2x. And my 5 plus 8 will become 13. So in order to make this my final answer, I'm just going to combine my plus minus right here. And it's going to become x squared minus 2x plus 13.